Hi guys. So I thought that it might be helpful coming out of hand simulation or coming into hand simulation, depending on when you are watching this, to sort of see where we're going. Because we're not always going to be doing hand simulation, and I know that a lot of what we do in lecture might seem kind of abstract and arbitrary. And so I want to sort of at least show you how something like homework B1 might look in a real simulation package, like Arena. And so let's see what that kind of looks like here. So I've opened up Arena, and so this is what Arena looks like. You guys will see this starting in Lab 5. This is the student version, so you can download this and run it yourself. If you got a Windows machine or a Windows emulator, you can run it from the labs. So the basic idea here, and so when you open this, it'll pop up a little window that says you can that it's a student version. If you've got the student version, what that limits you to is the number of entities that can currently be in a simulation at a particular time. So everybody knows what entities are now. And so if entities are running around inside your simulation, if you hit, I think it's 150 of them, you get an error message. And so in the commercial version, you can go to as many entities as you want. But in the student version, you have to make sure you build models that don't keep around a lot of entities, or else you get that. Now, if they leave the system, that's fine. You can kind of it just has to be 150 entities in the system at any instant. So entities are created using this little create block. So I can grab that and I can drag it over here. And if I double click on this create block, this is basically how we manage arrivals. And so I can say that a customer arrival, that's what I'm calling this kind of process. And I'm going to call this entity customer. So I'm kind of viewing this as sort of a homework B1 analog here. And I then, instead of providing it a list of inter-arrival times, I'm going to have the inter-arrival times drawn from an exponential distribution that has an average of 5 minutes. So I'm saying that on average, there's about one customer every 5 minutes shows up at the cashier. It, uh, it, it could be that I get one every minute, and then a big and then a big bit of idle time, or it could be that I get um, you know maybe one in 2 minutes, and then one in 10 minutes, and then one in 3 minutes. But they're basically just going to be drawn randomly, and I will have one entity show up every arrival, and I'm just going to let the simulation run. So there could be an infinite number of arrivals, and I get one right at the instant my clock starts at 0. So this is sort of where those inter-arrival times come from. So then those entities will eventually have to go somewhere. So that's this dispose block, and I'm going to put that over here, and we'll see that later. And I'm just going to rename that dispose block customer leaves, or customer departs. And then I need the cashier process, and so I put this process in between, and I am just going to call this one checkout line, or maybe I'll call it checkout line. And I don't have to worry about this stuff yet, but you can see under logic it is action delay, and I think I mentioned in class this is going to be something we'll call a seize delay release, because it needs to seize a resource, and we all know what resources are. Hold on to that resource for a certain amount of time, and then release the resource so another entity can use it. And so I then add a resource, and my resource is going to be called a cashier. And I have one unit of cashier that I'm adding to the system. So a cashier can handle one entity, and there's a fixed number of cashiers. And now whenever the cashier is being used, this is those service times. And I am going to, it doesn't have an exponential as one of the options, but it has this expression. And I am then going to choose exponential from my possible options here, and I'm going to say 2. So what that means is that, and then I choose my, I'm going to say minutes. So I'm saying here that service is on average 2 minutes long. Some services are shorter, a minute. Some services are longer, 3 minutes, 4 minutes, 5 minutes, but they draw from an exponential distribution that has a mean of 2 minutes. And that's how I get my service times. So all those inter-arrival times are here, all those service times are here, and because this is a seize delay release, it's put this little line up here, and we're going to see that's actually where the entities queue up. So I can wire these things together. So that's what I've done here. So I'm going to click that guy. All right, good. And then I will wire up the end of the checkout line to the departure. And there we go. And then these little numbers will end up being useful, so I'm going to make them a little bit bigger. And now if I, you can see they have little captions, customer departs that number out. This is going to count how many customers have left my system in the simulation. This one here, if I were to click on, it says it's customer arrival number out. This counts how many customers have arrived in my simulation. This one here says customer line.wip, work in progress. This actually tells me how many customers are currently being serviced. And then the customers waiting, there's actually going to show up in line in this little line up here. Now I don't need these to be so far apart, so I'm going to drag them close together. Okay. And if I then hit play, then you can see that I'm going to maybe hit pause here. Maybe I'll hit play again and see if I can pause it at a time. There we go. You can see that I've run this simulation. 202 customers have entered. 200 customers have departed. And there are 2 customers stuck in this process. So they are not both being processed right now. One of them's waiting. The other one is actually being processed. So this is like ls plus lq in your homework. And this is like lq, and the difference between that is like ls. Now, if I let this simulation run, I can hit stop. And it turns out that then I can generate reports from each simulation run that tell me a bunch of interesting things like what's the average amount of time that customers spent in the checkout line, et cetera, et cetera. And that's something that we'll get to later in the class. But for now, I'm just trying to motivate what goes on here. And so behind the scenes, Arena created an event calendar and actually stepped through those events in exactly the same way that you've been doing by hand. And so just to make this a little more fun, I'm going to add some plots. So I'll add maybe a little clock here. So I'm going to make this a digital clock that's a 24-hour clock. And, it's not the prettiest visualization, but there it is. And I'm also going to add a couple of plots. And so I can add, see it says data series. I can add some plots, and I'm going to maybe say that let's plot LQ, and so I can go in and do build expression, and I want to see the number of entities in queues. So if I go to these queues, I can see I've got all these different options here, and I'm going to say what's my current number in the queue, and it says which queue do you want? Well, checkout lines queue. All right, cool. So that's in there, and Arena's a little clunky. So, but this will kind of give you the point here. So I might turn on my major grid lines, and I might go down here and say I want the scale of this thing. I know that I'm probably never going to have 100 people in the queue, so maybe I'll make it 10. I'll make my major increment 1, and hopefully that's enough for this to be kind of usable. And then I go back and maybe I'll add another data series that will be my LS. So you think about homework B1. So what do I want for the expression? Well, I'm going to look at entities here, and I might look at. Oh, I'm sorry. I was thinking ahead in my. So I want to know how many entities are currently being worked on, right? So I'm going to go to resource here, and I'm going to go to state, and I'm going to look at the current state of the cashier. And I'm just going to say, if the current state of the cashier is busy, then this thing's going to look like a 1, and otherwise it's going to look like a 0. Well, that looks just like the ls variable in your homework. All right? And then I'm going to draw that plot, and let's say I'll put it over here. All right, doesn't look like anything special so far. Now I'd like to do one more plot. And so in this one, I'm going to add a series. And this one, I would like to know the average amount of time every customer, every entity, spends in the system. So I'll say average time in system, ATIS. And I can go to build expression. And this is something that's, I'm kind of interested per entity. So I go to times, and I'm interested in the average total time every customer, that's what I'm focusing on here, spends. And it gives me a little expression. And then I need to go, and I might turn on the major grid lines. Why not? And I don't really know how long this is going to be, so I will guess that the maximum of 100 is way too high. So let's do a maximum of 5, and I'll make my major increments I don't know, 0.5. Okay. And then I'll draw that here. Okay, so now if I run this thing instead with the plots here, and I'll maybe pause it, I apparently made some bad choices here on my grid increments, so maybe I'll go in and change that. So I'm just going to go in and say, you know what, I have no idea what the maximum is going to be. I'm going to make it low, like I'll make the maximum 0.5, and then it should auto scale. So maybe if I play this again now, apparently it's always under 0.5. So maybe what I'll do is I'll make my customers arrive a little faster, and I'm going to make my service take a little longer. So now my customers are arriving 3. Maybe I'll leave my service at 2. And so if I run that, then this is climbing, but it's still not reaching that major increment. So, so yeah, the visualization's not so great here. But if I pause this, you can see that we're getting a lot more queuing up. So in print, oh, there, now we had a major grid line here. So now you can see that on average, entities are spending roughly the same amount of time, like on average. So this is stabilizing at some point that's above 10 minutes in the system. And if I'm at this little snapshot here, I can see that I've got 4 between the server and the checkout line waiting. So I've got 3 waiting and 1 in the server. And if I look over here, that corresponds to what I'm seeing here. I've got 1 in the server, and I've got these 3 that are waiting. So, and I've had 185 come in, 181 leave, and the difference are the 4 that are still stuck in the system. So if I keep playing, then I see that sometimes my number of entities goes up, and sometimes it waiting, and sometimes it goes down. Um, and so you can see when it gets really long, like right here, that's when the entity limit of 150 entities, if I were to make the arrivals happen really, really fast, I might get really long lines. And if I got more than 150 customers waiting in line or 150 customers tied up in this, then the student version would snap and say, oh, you can't run the simulation this complex. But it's perfectly fine for something as simple as this. So again, you can see the average time in system is kind of stabilized. And for those of you who are taking 470 or are about to take 470, then this is an example of when simulation actually is probably not needed because it's such a simple system. I have exponential service times, exponential arrivals. This is an MM1 queue. And so we kind of know from 470, if you've taken 470, that it's going to have a nice, stable, steady state characteristics. And one of the things that we could study in that is the average amount of time everybody's going to have to wait in the queue. That's something that we could describe using relatively basic math in 470, and that's exactly what we're seeing here. Now, something that would be harder to study in 470 is exactly this series of how many times people, or how long this queue moves at any instant of time. So is it very long or very short? And then if I wanted to make this checkout line have a more generic, not necessarily an exponential service time, then that gets a little more difficult to study using the methods that you see in 470. Or if I wanted to make this process much more complicated, have other things forking off from here, have people balking if the line gets too long. Just like I can plot the number of people in here, I can actually make the logic that the entities flow through dependent on state variables like the number of entities currently in the queue. So I can implement balking, something that is a little more difficult to handle using the mathematics you learn in 470, at least initially. So that's why we have simulation to make things a little more complicated. For now, this is a little bit of a contrived case because this is something you could just do all in math. But I hope you at least see that this is basically exactly what you're hand simulating, but we were able to draw it out and run it, and we will eventually be able to get exactly the same stuff that you're getting out of your hand sim and export this into a format that we can then run statistical analysis on. And so that's kind of in the second half of the class how we end up handling that. But for now, we're building up to this. We'll get there eventually, but in the meanwhile, we have to do things like learn about, what the heck is an exponential distribution? How do I know when I'm going to use an exponential distribution? How do I know when I use maybe a different distribution here? If it is a different distribution, how do I choose those parameters? We're also going to have to learn that once I have the outputs, how do I compare those outputs to other outputs and make rigorous statistical comments and inferences about that. So those are other things we have to work on. But along the way, you're going to learn how to do this as well. And then by the time you do your final project, you'll be building simulation models for your final project. So that's just a little motivation for you, for those of you wondering where we're going. I hope that helps.